So as mentioned at the beginning, the questions in section 2 are the same as in section 1. They are just already written out. So these work exactly the same as what we've done in questions 1. It's just these ones are drawn out for us visually. So as we can see here, it works exactly the same. So we know our n values on either side. So if we map it out, primary is 100, secondary is 1000. Need the ratio, so we take the larger number, 1000, divided by the smaller number, which is 100, gives us 10. So we know that secondary is 10 times bigger than the primary. So we need to calculate voltage. So we know that VP is 24. We know from our ratio that anything on the right-hand side is 10 times bigger than the left. So for that ratio to be the same as that, for that ratio to be the same as that, this has to be 10 times. So 24 times 10, 240. So 1000 is 10 times bigger than 100. 10 is 10 times bigger than 1. 240 is 10 times bigger than 24. Again, 2b, same values, same equation, same setup. Process is exactly the same, whether it's your n value or your v value, your voltage. Just work it through. Remember, large over small, and that'll give you your ratio for your large against 1 unit of your smaller value. So primary, secondary, primary, and this one is 250. Secondary is 50. This one's the opposite way around. The primary is larger than the secondary. Need to calculate our ratio. So 250 divided by 50. 5. We know. So in this one, again, the value relates to the ratio of the larger number. So we know that this is actually a 5 to 1, so it's a reduction. So we know that anything on this side is 5 times larger than anything on that side. So we know our VP, voltage primary, 12. So we would take a 12. And we know that that's 5 times bigger than the other side. So we have to divide that by 5. Which is 2.4. Your voltage on your secondary is 2.4. When you're doing them, just make sure you remember that value is calculated for the large number, and just make sure you remember, if that's actually a multiple of the unit where there's only one. So 3 is similar to 1E, so it's asking for the NS, but it works exactly the same. So if we map it, we have our voltage, which is 12 volts, against our secondary, which is 24. So 24 divided by 12 is 2. 2 relates to the larger number, so because we want 1 relates to the small number, the number calculated relates to the larger number. So we can see that actually 2 is twice as big as 1. 24 is twice as big as 12. Or 12 goes into 24 twice. 1 goes into 2 twice. So that's for our ratio. We need to calculate the number of turns. So we know that MP is 100. Primary. So we know that anything on the other side is 2 times the amount on the secondary side. So we would need to take the 100 times that by 2, which gives you 200. So the secondary set of windings would be 200. So 24 is double of 12, 2 is double of 1, 200 is double 100. So the ratios, the amounts are all the same for each of the different units.